Hey, how you doing? I think that this is a time to move our player. Let's open the script. We need to get some input from the user to know whether we want to move our player on the horizontal axis, which is X, or the vertical axis, which is Y. That's why we'll create a variable which will hold this value. So let's type float, and that will be X direction equals, and now we need to use some input from the user. So let's type input. Now we will use get axis, and we might choose get axis or get axis row. Let's choose the first one for now, and later on I will show you the difference. And now, because we are using the horizontal axis, we need to type it in. So use quotation mark and type it horizontal. It has to be typed in exactly as it is. You can't make a mistake because it's not going to work. And now I will show you how it works. We will debug this variable. So debug.log and x there. So this is taking input from the user. Whenever we use left and right arrow key or A and D on the keyboard, it will return some float value. Let's see. Go back to the Unity and open console window, press play. And now you can see that in the console there is a value of 0 because I don't touch anything. My hands are here. But now when I press right, look, we are getting number 1. I'm releasing, it's 0. Now I press left, we've got -1. So this is how it works. It will get the value from -1 up to 1. If I press left, it returns -1. If I press right, it returns 1. So this is how we will decide which way the player should move. And we can do exactly the same thing with the vertical axis. We can create a float. Let's say it will be y there equals, and now I will get input get axis, but here we need to use vertical. So now we have two directions for our player movement. But of course, it doesn't make our player move just yet. We only get some values based on the keyboard. So how can we move our player? We can use transform component. So let's do that. We can call transform component in a very short way. We can just type transform. Now, after the dot, we want to use a special method to move, which is translate. And now inside of this method, you can see that it takes vector 3 parameter. So we need to create a new vector which is made of the horizontal and vertical direction. So let's type new vector 3, and here we will put x direction, y direction, and with the z axis we want to keep our player at 0. Okay, so let's test it. Let's go back to Unity and press play. And now I move to the right. Whoa! Did you see that, guys? It went so much to the right and up and down. It pretty much works, but it moves like crazy. And why is that? I don't know if you remember, but update method is executed many times a second. A lot of times, especially when the computer is quite powerful and the scene is very simple. In that case, we need a way to compensate it, to stabilize it, so our game looks and plays exactly the same on any computer. And how can we do that? There is a solution. Unity gave us a solution. Whenever we use an update method, and we need to make sure that it will work the same on different computers, we have something called time delta time. So our vector needs to be multiplied by time delta time. So now I will type time delta time. And this time delta times return the value that passed from the last frame. It is a fraction of the second, and it will be different for each frame and for each computer. That's why it will make everything looks the same. So let's go back and have a look. Now if I press right arrow, it goes to the right, now up, left, down, and it looks like it's working. But now it's too slow, isn't it? So in that case, we of course need some variable that will define our speed. So let's do that. Let's go on the top, put it in a float and call it a speed equals to, let's say 5. And now the whole vector needs to be multiplied by the speed as well. Ta-da! Looking good. Go to the right, go up, left, down, ta-da! Looking good. But I don't know if you notice, wherever we start moving or finish moving, there is like this smoothing effect. And this is because we are using this function getAxis. And it returns the value from 0 to 1 and -1, but there is something in between as well. But if we don't want this value in between, we don't want this effect to, speed up and slow down, we can use instead getAxis row. GetAxis row is similar to getAxis, but takes only values either 0 or 1. There is nothing in between, and that's why there is no slowing down effect. Let's save the script and go back. Let's have a look. Now let's go to the right, up, down, and everything is working fine. Okay, but there is one more thing I need to show you. Whenever we go to the right or up, it's okay, because we've got a straight vector. But if we go diagonally, or whatever you call it, then it looks like this player is going faster. Why is that? It is because our vectors are being added. So if we have a vector going to the right with the value of 1 and vector up of value 1, then when we go in between, those two vectors adds up and its value is bigger than 1. And we need to make it smaller actually. We need to clump it so it's never bigger than 1. And there is special method called normalize, and thanks to that, the speed of our player should be equal. So we have to go in here, and whenever we create this vector, add a dot and we type normalized. And now it should be fine. We go to the right, to the left, diagonally, and yes, it is looking nice and lovely. Good. It looks like our player can move and everything is fine. Look, we used only like 3 lines of code plus speed, and it allowed us to move our player, which is really nice. But now I would like to show you how I would refactorize this code to look a little bit better, because this line of code is a little bit long and I would like to make it a little bit different. Let me show you. There's nothing wrong with what we've done now. I just want to show you some different ways so you can learn something. We have our X direction and Y direction, so why not make a vector of this direction in here? Let's do that. We will create vector 3, call it, let's say direction, equals, and now we will type new vector 3 and we will make it of those two values. This is nice, I like it. Now we need to normalize it. So let's use dir and then use normalize. But we'll use a special method instead of the property as we used in here. So you can see we did something like that instead of that. I will do something like that with increment operator. So multiply equals, and let's put speed. And now we can make this argument much shorter. We'll only type here the direction multiplied by time delta time. And as you can see, this code looks a little bit better in my opinion. But as I said, there was nothing wrong with the code that we've done before. I just wanted to show you a different ways of doing that. And of course, in the end, we can make this value serialized field, so we can adjust this speed value in the inspector to see what's the best value and how this game looks like. Now I would like to show you where this horizontal and vertical comes from, so you can know that for the future. Let's go to the edit and to the project settings. Here we've got input manager section, and now you need to expand the axis, and here we've got horizontal. You can see the name, that's why we had to type it in exactly the same. And we have left and right arrow. We have A and D as well. And additionally, we've got support for the pad. So if you connect the pad to your computer, it will work as well. And beneath you, we've got vertical, which works similar. And we've got few more that we are going to learn later on, not today. So this is where you can find those. And this is a really nice way of making input because it's going to work on keyboard and on the pads. So it's quite universal.